Sorry, part 2 on comets, right in the middle of my story. But yeah, they were people, charlatans, that would go around selling these magic pills. They were just sugar pills, telling people that if you bought these, it would keep you alive when they went through Halley's Comet's tail in 1910. Yes, we went right through the tail. Did it affect us? No. Were there noxious gases that hurt anybody? No, that was all made up. The scientists knew that was the case at the time too, but it's easy if the public is uneducated and doesn't think for themselves for them to believe these kind of things. Especially when people start saying it and they say it loudly enough, they start to make it sound like it's right when it's based on no facts at all. Same problem we have nowadays, especially when we get close to election times. All right, this is Comet West. This is another bright one. Typically, about every 10 years on average, we get a bright naked eye comet, a comet that you can see without having a telescope. Now we're kind of overdue. We had a couple around the year 2000, and there was another one in the 2010 region, McNaught. The problem was it was only visible from the southern hemisphere, so it didn't do any good for us up here in the northern hemisphere. But we're kind of due for another one. But they just kind of come and go. Just to show you, this is Halley's orbit right here. But you see it's at a weird angle, so this is from the side. This is Pluto's orbit. Remember I was telling you how Pluto's all messed up? Well, Halley's is even way more messed up. And Halley's comet comes in all the way inside of the Earth's orbit, right in here. Yeah. But it goes out past Neptune in its 76-year orbit. So it's got a kind of crazy orbit, but it's angled. It's not going to hit any planets. It doesn't come in the same ecliptic plane as any of the other ones, which is why it's still around. This is Comet Schwarzmann-Wachmann, which is just kind of fun to say. A couple of Germans found it, Schwarzmann-Wachmann. And one of the neat things about it is when they found it, it started breaking into pieces. And then we had a whole bunch of pieces, and each of those pieces then was melting. And so each of them made little tiny comets. Hey, we see that before. Remember when Comet Shoemaker-Levy smashed into Jupiter? Before it smashed in, it broke into about 20 pieces. So that's not an unusual thing. So let's talk about what's the fate of a comet. The problem is every time the comet comes around, like Halley's Comet, every time it comes around the sun, it's losing tons of ice as it melts. So comet fate. The fate of a comet is, one, it could just melt away. Eventually Halley's Comet's going to melt away, there's not going to be any ice left. Two, it could do like Comet Shoemaker-Levy, it could run into a planet or the sun. We've seen comets run into the sun. And the sun didn't even notice it. They're just gone, vaporized. Or they could break apart like Comet Schwarzmann-Wachmann does into many other pieces, and then each of the pieces just melts away. Or it could become a C-type asteroid, meaning the outer layer gets so coated with material it can't melt anymore. Now we don't call it a comet at that point, we call it an asteroid, but it really started out as a comet. Alright. So that's one of those fates will happen to any comet that's a periodic comet. Where do comets come from? Well, most comets seem to originate in a place called the Oort cloud, named after an astronomer that studied this. So what we have is, here's the solar system, here's the sun, here's all the planets out to, that's supposed to be Pluto, out to Pluto right here. Okay, that's the solar system. The Oort cloud is this region of space way out here, way beyond Pluto, and this is where we think there's just chunks of ice hanging out here. And it goes all the way to like halfway to the next star, Proxima Centauri. So So there's just these chunks of ice. And then for some reason, we don't know, maybe they get too close to each other or something like that, but one of them will get thrown towards the sun. And then it'll go around the sun and it'll come all the way back out to that orbit unless it gets too close to a planet like Jupiter, and then it'll change its orbit and it'll get trapped. And that's what happened to ones like Halley's Comet and all the ones that we see that repeat every so many years, is they got close to a planet that changed their orbit and they got captured by the sun's gravity. Otherwise, they just seem to go all the way back out to the Oort cloud. That's how we know the Oort cloud exists, is we see these one-time comets. Here's an example. This comet Magnat I mentioned in January 2007. Pretty comet. You just couldn't see it from the northern hemisphere. But look at how far away it is. 5,681 AUs. That's, yeah, way out there. Half the distance to the next star. And remember, from Kepler's law, p squared equals a cubed, right? So we can calculate exactly what its period is. Luckily, I got my calculator right here. Let's figure out when it's going to come back. So all I have to do is take p and take the square root of 5,681 cubed. Well, let's see what I get. So 5,681 to the third power, and then the square root of that. And guess what? It'll come back. It has a period of 428,190 years. So talk about your long-term calendar. But that's why we know that these, where the Oort cloud is because we see these objects, and if A is that much, remember double that is the semi-major axis. That's where it started from. So it started from 10,000 or 11,000 some AUs away, very long way, before it started to fall into our solar system. All right, so yes, we're not going to see that one again anytime soon. And that's all I have for comets. Remember, comets are icy, asteroids are rocky.